Let's look at problem number 1 from worksheet 2. So here we have a piano string that is 1.1 meter long and has a mass of 9 gram. So the question is, how much tension must the string be under if it is to vibrate at a fundamental frequency of 131 Hertz? What are the frequencies of the first 4 harmonics? So we want to find the tension, and we know that tension is related to the speed of the wave in the string. So we can use this equation: V equals square root of tension over mu. So in order to find tension, we can square on both sides. So V squared equals square root of T over mu, and we are squaring that. So we have V squared equals T over mu, and that gives us T equals V squared times mu. So in order to find tension, we need the square of velocity and mu. Now mu, we can find that by using the formula for the density, linear density of the string, which is 9 mass times length, which is 1.10 meters. And we want to express this mass in kilograms, so that gives us 9 times 10 to negative third kilogram and 1.10 meters. So if we do the calculation, we get 8.18 times 10 to negative third kilogram per meter. So we got mu. Now we need to find V, and we have equation for V. So V is lambda times F. So we need to find lambda because we are given F. So once we know lambda, we can find the velocity, and with velocity we can find the tension. So let's find lambda. Here we see that this is the first mode because there's one antinode. So, or we can just say that in this length L, length between the node to node, there is half the wavelength. So this length fits half the wavelength. How do we know this is half wavelength? Because if we look at this, so this would be the full wavelength, like this would be the full wavelength, and we only have half wavelength here. So this is the first mode. So lambda 1 equals 2 times L. So 2 is lambda 1 is 2 times length is 1.10 meters, and that gives us 2.20 meters. Okay, that's the lambda. Now with lambda, we can find the speed. So speed equals lambda times frequency. So 2.20 meter times frequency is what's the given frequency? So the frequency is 131 Hertz. Now we need to calculate that. That gives us 288.2 meters per second. Now with that, we can find the tension. So tension equals V squared over mu. So V squared is 288.2 meters per second squared, and mu is 8.18 times 10 to negative 3 kg per meter squared, and that gives us tension of 678.6 newtons. Okay, so it's asking for us to find 4 harmonics. So we can find the 4 harmonics by using this equation. So we can write frequency of different modes equals mode times the fundamental frequency. So the first harmonic is just the fundamental frequency, which is 1 times the frequency. That is 288, no, that is 131 hertz. And then all we need to do is the second harmonic is 2 times the fundamental frequency, F3 is 3 times the fundamental frequency, and so on.